This is a problem of seated in a round table. You have 4 boys and 4 girls. Now there are no restriction, means the 4 boys and 4 girls can sit anywhere, but basically you are saying 8 people in a round table. So no restrictions. I think it's not difficult. Basically 8 individuals in a round table. So you can think of it as 1 times 7 factorial, or 8 minus 1 factorial, which is 7 factorial. Done. Simple and straight, right? Because it's in a circle. Done. Part 1 is done. Part 2. Find the number of ways for which no two people of the same gender must sit next to each other. Basically, this is saying boys and girls are separated, or you can think of it as because there are exactly 4 boys and 4 girls in a round table, then they must alternate. Right? It's basically alternating. So separated. So one way to look at it is, let's say we can sit the boys first. So you have 4 seats here, right? You sit the 4 boys in, but because it is a round table, to sit the 4 boys, it is not 4 factorial, it is just 4 minus 1 factorial, which is 3 factorial. Now, after you have seated the boys like that, B1 to whatever, this is one particular arrangement, then you will sit the 4 girls. Now, the 4 girls then cannot be cannot be seated anyhow. They must be in between any 2 boys. So you have actually 4 slots. Now, in these 4 slots, it's not about seating since the boys are already seated in a particular way, right? Then you will arrange the 4 girls using 4 factorial because there is already a relative position fixed. Yes, so you sit the 4 girls in. There are 4 ways to do sit the first girl, right? 4, right? Why 4? Because it's 1, 2, 3, 4. These 4 are distinct. So 4 times 3 times 2 times 1. So it is 4p4 or 4 factorial, either way you want to do it. So therefore, because these operations occur in succession, you use the multiplication principle. So take note, it is not 3 factorial times 3 factorial. It is also not 4 factorial times 4 factorial. These two are both wrong. Right? So first you need to sit one agenda first, then followed by the other. A common question is, can we sit the 4 girls? Yes, of course you can sit the 4 girls. Yes, you will get the same answer anyway. Right. Part 3. What if now one particular girl must sit in between 2 particular boys? Now, the word particular is important. So let's, for discussion's sake, let's see the particular girl is G2. The 2 particular boys is B1 and B3. Alright? So these 2 are particular. It cannot be any other 2 boys. It cannot be any one girl. So these are fixed. So the way to do it is group the 3 as a unit. This is one unit. Then sit this unit together with 1, 2, 3, 4, 5. 5 other units round a table. Alright? Sit them around the table. So which means you have 6 units. Then minus 1, you actually have 5 factorial ways of arranging these 6 units around the table. So put them in. Yes, you put them in, arrange, therefore you get 5 factorial ways. That's not really the end, because your B1 and B3 can swap places. It only says that this particular girl must sit in between the 2 boys. It doesn't say that there's a particular order. So therefore, you must take like that, right? 5 factorial times 2 factorial, you get 240. Next, last part. Now you want one particular girl must sit between any 2 boys. So this time it's just this special girl, but the 2 boys can be anybody. Can be any 2 boys. So one way to do it is, beside her must be 2 boys. What you can do is you take 4 ways times, because the left hand side and right hand side, this is 4 ways, this is 3 ways. Or you can take 4p2. These 2 are exactly the same. 4p2, it was the same way. That means out of 4 boys, you permute 2, you arrange the 2. Right? So this one, for example, these 2 like that. Then you group them as a group. Treat the 3 people as one unit. Then again, same thing. 1 unit, 2 unit, 3 units, 4 units, 5 units, 6 units. So therefore, you have a 6 minus 1 factorial, 5 factorial. And that's that. Now, the common mistake here is how come when I do 4p2, some of us may take 4p2 times 2 factorial times 5 factorial. This is wrong. You don't have to do another 2 factorial. Why? Because the moment you take 4p2 here, the moment you take 4p2, you have already taken into account the swapping of the b1 and b3 because it's 4p2, 4 ways and then 3 ways. Your b1 and b3 was already counted when you did 4p2. So you do not add an extra 2 factorial here. Right? An alternative way of looking at this is a bit unorthodox. Personally, I don't recommend this method, but some of us may think of it like that. I can't stop you, but I honestly prefer this method. So an alternative way I'll go through very, very quickly is, let's say I want to sit the 4 boys first. If you don't understand this method, please skip this totally. I sit the 4 boys in a round table first, all right? Then therefore you get 3 factorial ways. But since the one particular girl must sit in between the 2 boys, right? There are actually 4 slots that you can slot the G2 in. That this particular girl, I slot the G2 in. Done. Now, once I slot the G2 in, I beg your pardon. See, once I slot it in, this 1, 3, and 4 cannot go in between these two. Cannot go in between these two. She can only be seated. This girl, for example, can only be seated here, here, or here. There are only 3 ways, not 5 ways. So therefore, that gets the 3. But once the first, correct, like that. But once the G1 is in like that, then the other G2, the other G3 can go between 1, 2, 3, 4. So that's why you get a 4. Correct? Then the last one, you have 5 ways. That's how you get the 5. So answer will still be the same, but it's a little bit unorthodox. I don't really recommend it, even though it is technically not wrong. Thank you.